Hello everyone, welcome to the experiment 3 for the principles of general chemistry, separation of dyes in candies by paper chromatography. Firstly, I will briefly introduce some basic background. You may wonder what the chromatography is. The chromatography is a physical method for the separation and identification of a specific chemical component in a mixture. In this experiment, we will separate and identify the dyes that are used to produce colors for the share of chocolate candies by using paper chromatography. The separation is based on the different distributions of the components between the stationary phase and the mobile phase. The stationary phase is a solid that has large surface areas, where the chemicals can be absorbed, and for the mobile phase, it is solvent, which is forced to flow over the stationary phase. In this experiment, the more soluble components will be transported faster. In contrast, the components that are strongly absorbed by the stationary phase will be transported slower. These differences in traveling speed will allow the components in the mixture to be separated. In paper chromatography, a small spot of the mixture to be separated is applied onto paper, which serves as the stationary phase. The solvent is allowed to flow up the paper through the spot by capillary action. The compounds separated can be described by their retention factor, or the RF value. In this formula, di is the distance traveled by a specific compound, and ds is the distance traveled by the solvent. Here we go, let's start our experiment. As you can see in the picture, the chemicals and devices we used in this experiment are very simple. In the first step, you need to place chocolate candies with different colors in 6 cavities. Then, add 3 drops of 1% sodium chloride solution into each cavity. Wait for about 3 minutes until the dyes are dissolved into the solution. If necessary, you can use a commercial hair dryer to evaporate some water to concentrate the solution. Then, you need to draw a straight line with a pencil from the short edge of the chromatography paper. Please do not use a color pen or ball pen. Along the line, mark 6 spots that are separated from each other by about 1 centimeter. In the next step, you need to apply a few drops of the color extract onto a pencil mark with a capillary tube until the color is visible. To minimize the spot size, you need to make sure they are applied exactly in the same position. Label the color of the spot using a pencil, repeating this step on different pencil marks for each color extract using a clean capillary tube. After all extract have been applied, fold the opposite end of the strip over a glass rod and hold it in place with paper clips, and the length of the strip should be adjusted to fit into the beaker. And next step, fill the beaker with 50 ml 1% sodium chloride solution to a depth of about 1 centimeter. Put the glass rod with a strip across the top of the beaker. Ensure that the end of the strip rests in the solution but does not touch the base of the beaker, and the solution is below the level of the spots. Cover the beaker with aluminum foil. The solvent will gradually rise by capillary action, carrying the components in the spots along. When the solvent film has reached about 1 cm below the folded part of the strip, carefully remove the glass rod. Immediately mark the solvent film with a pencil, and then dry the paper strip with a hair dryer. Please identify the colors of the component dyes for each spot. Circle the position of the most intense part of the separated color. Measure the distances from the original positions of the spots to the solvent front and to the center of color components for each Candies. Repeat step 2 to step 7 using deionized water as a mobile phase. In this experiment, 2 mobile phases have been adopted. They are sodium chloride solution and water. The result of using 1% sodium chloride solution is on the left, and the result of using water is on the right. You can simply compare these results by yourself. The RF values of each component can be calculated by the equation mentioned above. The table shows the calculated RF values. According to these RF values, some conclusions can be drawn. For example, compared with water, the sodium chloride solution showed a better separation. In addition, the DI value of blue number 2 dye is 0, indicating that it has the strongest interaction with the chromatography paper. That's all for the experiment 3. Thank you for your attention. If you have any questions, please feel free to contact us. Bye bye.
Hello everyone. Today our experiment is evaluation of antioxidative capacity of food substances with Glowsticks. It contains 5 aspects: intended learning outcomes, introduction, chemicals, equipment, experiment, results, and discussions. So first is XIAO. After this course, you are expected to explain the luminescence and chemiluminescence, explain and classify the reduction and oxidation in redox reaction. Then, I hope you can describe the chemical reaction in Glowstick and compare the antioxidative capacity of food substances. So first, what is luminescence? Luminescence is the emission of light by a substance for any reason other than a rise in its temperature. In general, atoms of substances emit photons of electromagnetic energy when they return to the ground state from an excited state. There are mainly 4 excitation sources: photons, electrons, living organism, and a chemical reaction. They are also called photoluminescence, electroluminescence, bioluminescence, and chemiluminescence respectively. Today, we will learn chemiluminescence. Chemiluminescence is luminescence resulting from a chemical reaction, such as the slow oxidation of phosphorus. And first, we introduce redox reaction. It's very important. Actually, redox is a word which combines reduction and oxidation. An oxidation-reduction reaction is a type of chemical reaction that involves transferring of electrons between 2 species. They are oxidant and reductant. The oxidant gains electrons and oxidation number decreases. This process is called reduction. while reductants lose electrons and oxidation number increases. This is oxidation. Antioxidants can react with reductants, so the oxidation is stopped or slowed down. Here is an example. Hydrogen burning. Hydrogen is neutral and oxidation number is 0. During the burning, one hydrogen atom loses 1 electron and oxidation number increases to 1. This is the oxidation process of hydrogen. So next is a new term, antioxidants. Antioxidants are compounds that inhibit oxidation. Oxidation is a chemical reaction that can produce free radicals, thereby leading to some chain reactions that may damage the cells of organisms. Antioxidants such as thiols or ascorbic acid, also called vitamin C, can stop these chain reactions. Antioxidants give an extra electron to the free radicals. After free radical is neutralized, the chain of free radicals stops. This reduces your risk of most diseases and slows aging process. So I suggest you guys eat more fresh vegetables and fruits. Redox reactions are very common in biological and food systems. Many naturally occurring substances such as vitamin E and polyphenolic compounds possess antioxidant capacity. The term antioxidant applies to all substances that can retard oxidation. These natural antioxidants are commonly found in vegetables. For example, artichokes, green tea, spinach, strawberries, and some other vegetables have rich antioxidants. Next is the luminescence mechanism of glow stick. By mixing the hydrogen peroxide in a glass vial with a phenol-oxalate ester, a chemical reaction takes place, yielding 2 moles of phenol and 1 mole of peroxy acid ester. The unstable peroxy acid decomposes spontaneously to carbon dioxide, releasing energy to excite the dye. When an excited dye relaxes to its original ground state, a photon is emitted. The wavelength of the photon determines the color of the emitted light, which depends on the structure of the dye. The reaction releases energy mostly in light with very little heat. So then we introduce the mechanism of this experiment. After mixing the acyl acetate extract of the food sample, antioxidants also react with hydrogen peroxide, suppressing the redox reaction involved in the chemiluminescence of glow sticks, which causes the decrease in emission intensity of the glow sticks. So the stronger the antioxidant capacity, the weaker fluorescence intensity. In the redox reaction of glow sticks, hydrogen peroxide is oxidant. Phenol-oxalate ester is a reducing agent. In this experiment, the antioxidative capacity of various food samples will be qualitatively evaluated based on emission intensity. So now we will introduce the material used in the experiment. We will use food with different antioxidants such as green tea, apple, mushroom, pepper. We will also use acyl acetate and glow stick. Some glassware will also be used, such as test tubes, a graduated cylinder, small conical flasks, dropper, and glass rod. Besides, we also use cutter, filter, balance, scissors, and tweezers. Now we will start our experiment. Firstly, we will calibrate the balance. Put the glass plate on the balance, then press tail on balance to clear to 0 and wait until the balance is tailed. You can see 0 in the screen, which means balance is tailed. The sample preparation. After calibrating the balance, we weigh around 2 grams fresh food sample and 0.2 grams of tea, respectively. Then we transfer the food to the conical flasks and label the sample and test tubes. In step 7, we add 10 ml of XIAO acetate using cylinder. And the detailed procedure of step 7 are described here. We measure the liquid with help of a measuring cylinder and a dropper. Then add XIAO acetate into conical flask with food sample. Then we cut and smash the sample into small pieces with scissors and glass rod. Eventually, we got the samples. Now, we will break the glass tube in Glowsticks. After shaking it over and over again, snap the glow stick using cutter and filter the solid until all the liquid is added into the flask. For this procedure, please see video for the detail. Now we snap it. We can see it emit very bright luminescence. Then we use the scissors to cut it. You know, inside the glow stick, it has some small glass pieces, so it's a little bit dangerous. So the demonstrator will help you in the lab. Then we pour all the liquid out and we filter the glass pieces, use this filter. So we make sure we pour all the liquid out because we need many glow stick liquid. Okay, so now we go to the next step. In step 10, 2 ml of glow stick liquid is measured and added into each test tube respectively. Then measure 2 ml of XIAO acetate extract of food substances and add into each labeled test tubes. Then allow the mixture to stand for 3 minutes. In step 13, we record the fluorescent intensity changes and compare them. We get 6 samples: paper, Fuji ample, mushroom, green apple, green tea, and a reference. As a result, we found the paper has the strongest antioxidative capacity and green tea is the weakest capacity. This is all about our experiment 2. And here we also leave a question for you guys. Think about it. Is there any other food examples that has good oxidative capacity? Thank you.
Hello， 大家好，我係 Tweety， 今日帶大家嚟實驗室一齊做實驗。咁咧，我今日咧就想同大家做一個關於量子化學嘅實驗。喺呢個實驗入邊咧，我就會做一個好神奇 嘅現象俾大家睇嘅。咁咧，如果實驗成功嘅話咧，大家就會見到一個黑色嘅火。咁可能你會問我無端白事整咩黑色嘅火啊？咁咧其實就係透明茶小子嗰日上完呢一個化學堂，咁我哋學完呢個彩色嘅 flame test 之後咧，咁佢就問我可唔可以整黑色喎？咁我覺得個 idea 唔錯，所以我哋今日就一齊嚟試下啦。同大家講解一下我身後準備咗去呢度有啲咩實驗材料嘅。首先咧就有我哋今日嘅第一主角呢個好似比薩斜塔咁樣嘅玻璃管，咁咧呢一嚿嘢咧其實係一盞燈嚟嘅，咁因為咧係要自己砌嘅，所以咁佢就有少少醜樣啦。咁你可以見到我嘅手工不足啊！呢一盞燈咧點解會咁奇怪嘅樣咧？咁其實咧佢就係一盞蠟燈嚟嘅。Focus 呢度好冇？啊，得啦，咁咧。蠟燈顧名思義咧，入邊就係有好多蠟喺度嘅。咁喺呢個玻璃管入邊咧，就有好多呢啲銀色嘅珠珠啦。咁呢啲珠珠咧就係嗰啲蠟嘅金屬擺咗喺度啦。第二樣我哋需要嘅嘢咧，就係需要一個燃料。咁就有咩methanol爐做燃料啦。咁呢個就陣間裝落去。咁然之後咧就會有呢一個水啊。咁咧，仲有第二主角就係呢一兜嘢，呢一兜咧，只不過係普通嘅食鹽嚟嘅啫。咁但係佢就係我哋今日嘅第二主角，整唔整到呢個火咧，就係靠佢噶啦。咁同埋仲有最後，我哋有一個火機。咁咧喺做呢個實驗之前咧，咁我哋就要有少少嘅準備嘅。咁就係首先要整一杯鹽水。然之後我哋就會準備我哋嘅火焰啦。咁喺任何時候做危險嘅實驗，記得要保護好自己。哇！
好笑啊！
使唔使攞翻個 coupon 俾你啊？
我點花生糖？
咁大家而家可以見到啦，呢一個甲醇點。methanol係咪甲醇啊？如果唔係，我咪成條片都講錯咗咯。甲醇啦。好嘅 ，OK。咁而家大家可以見到啦，甲醇咧點着咗咧就係一個藍色嘅火嚟嘅，而令到呢一個藍色嘅火變成黑色咧，就係呢一盞蠟燈出場嘅時候啦。咁大家可以見到，而家開着咗呢盞蠟燈咧，咁佢咧就會發出呢個非常之奇怪嘅橙紅色嘅燈嘅。咁咧佢喺慢慢通電多一段時間嘅時候咧，就會變成橙色噶啦。咁喺呢一個蠟燈通電嘅時候咧，喺個燈入邊嗰啲蠟嘅原子咧就會被電流激發到佢哋嘅激發狀態。咁咧由於所有嘅原子咧都會傾向想要回復一個冷靜啲嘅基態，咁所以咧當佢哋被激發嘅時候咧，咁佢哋跌翻落去基態嘅時候咧，就需要將呢一個能量掉翻出去嘅。而佢哋掉翻呢個能量出去咧，就會以光子嘅形式掉翻出去，咁所以咧就會產生我哋見到嘅呢一個橙色嘅光啦。咁而家咧我就會去熄晒呢間房其他嘅燈，等呢一個蠟燈咧就會成為我哋嘅主要光源嘅。我熄燈喎。咁咧，而家呢一間房咧，全部嘅燈都已經俾我熄晒啦。咁蠟燈同埋呢一個火咧，就係我哋唯一兩樣識發光嘅嘢啦。咁好啦，為咗咧要介紹下呢個蠟燈究竟有幾特別咧，咁我就開咗我自己嘅電筒俾大家睇下，我原本嘅手指甲係咩色先。係啦，咁然之後咧，我就會熄咗我個電筒，大家再留意一下，當只有蠟燈做光源嘅時候，我嘅手指會變成咩色啦。大家有冇留意到而家所有嘅嘢都只係得橙色或者 好似黑白咁樣單調嘅色呢？咁個原因就係因為呢，而家只有鈉原子激發出嚟嘅光子，所以呢就只有呢一個鈉指定嘅光譜，所以呢所有嘅顏色呢喺呢一個嘅光下面呢都會變成不同深淺嘅橙色同埋灰色。咁但係呢，我哋仲未達成目標，我個火仲未變成黑色嘅。咁啊，大家可以睇下我哋個火。咁呢喺呢一個光線底下呢，其實個火呢係基本上係睇唔到嘅。咁因為呢，佢都係一個發光體啦，而佢嘅光嘅能量呢亦都唔夠呢個鈉燈高，咁所以呢，可能呢就會難睇到少少嘅。咁我哋而家呢會做嘅呢，就係將我哋頭先準備嘅鹽水就加入去呢一個火入邊。見到啊！係咪好神奇呢？咁呢一個就係黑色嘅火啦。你要唔要睇黑色嘅火啊？你過嚟望下呢個火。睇住先啦，佢個邊會變咗黑色㗎。咁當我喺另外一次做呢個實驗嘅時候呢，就發覺原來 iPhone 個相機呢就會影到呢個效果好好多嘅。咁你可以喺呢條 iPhone 片度見到啦，嗰個火呢係真係成個都變咗做灰黑色嘅。咁相信大家都一齊見證到我哋今日做呢個實驗係非常之成功嘅。咁我哋就成功做咗一個黑色嘅火焰出嚟啦。咁呢，我相信大家而家一定係非常之疑惑，到底呢個現象係點樣產生噶啦。咁就等我而家簡單咁樣講解俾你聽啦。咁首先第一樣我哋要知道嘅就係喺呢個鈉燈有鈉嘅原子成分，咁而喺呢個火入邊呢，我哋加入咗好多嘅鹽水啦，咁所以咧呢一個空間呢，亦都係充滿咗非常之多嘅鈉原子嘅。由於每一種元素被激發所需要嘅能量呢，都係唔一樣嘅，咁所以咧呢一個橙黃色嘅光譜呢，就係屬於鈉原子指定嘅發射光譜。咁而喺呢個火度呢，由於佢充滿住好多我哋加落去嘅鈉原子啦，咁喺呢一邊處於基態嘅鈉原子呢，當佢哋接觸到呢一個由鈉燈發射出嚟嘅光子呢，由於呢一個能量值差距呢係啱啱好夠激發佢哋嘅，咁所以呢，根據量子化學呢，佢哋係會選擇吸收咗呢一啲由鈉燈發射出嚟嘅能量嘅，咁所以咧呢一個火咧喺呢一個時候就會由一個發射光線嘅狀態變成吸收光線啦，咁所以咧就會產生咗呢一個黑色火焰嘅現象啦。咁我今集製造黑色火焰咧就嚟到呢度啦。如果大家中意呢條片嘅話咧，記得要俾個 like 支持下我。如果你中意睇更加多嘅科學實驗嘅話咧，就記得要訂閱呢個 channel 啦。咁我哋下次再見啦，拜拜。
有少少似一個奇怪嘅工場。
Hello， 大家好，歡迎翻到嚟新一集嘅港女科學家。咁今日咧呢一集咧，我哋就會一齊釀啤酒嘅。今次呢一條影片入邊嘅所有材料咧，都係由我嘅老細林潤華副教授贊助嘅。咁我哋今次釀啤酒嘅實驗材料咧，就係有非常之多嘅，咁所以就一路做一路講解啦。咁第一步咧非常之重要，就係要徹底咁樣清洗同埋消毒所有嘅用具嘅。如果唔係咧，就會影響嗰個啤酒嘅味道同埋發酵嘅情況嘅。跟住呢一步咧就叫做糖化啊。咁咧我哋就會先將一煲水咧加熱到71度，然之後咧就將麥芽咧加入去，維持喺呢個66至68度咧就煲佢60分鐘嘅。 喺呢一個用熱水泡浸麥芽嘅過程入邊呢，就會激活咗麥芽入邊嘅麥芽酵素，從而呢令到將儲存喺麥芽入邊嘅澱粉呢轉化成為一啲可以被發酵嘅糖分嘅。
One eternity later，
當糖化嘅過程完成之後呢，就可以利用呢一個濾網，就直接將所有嘅麥芽渣滓過濾出嚟啦。之後我哋就會利用呢個比重計去量度一下我哋啱啱整嘅麥芽汁嘅沸騰前重力，亦即係呢個液體嘅密度。如果嗰個重力達到一個合適嘅範圍呢，就可以進行下一步啦。
呢個倒咗。起啦，呢個唔入得㗎啦。起啦。
喺煲煮呢個麥芽汁嘅時候呢，就會分3次加入2種唔同嘅啤酒花嘅。啤酒花喺煲煮嘅過程之中呢，就會釋放出主要為綠草酮嘅 alpha 酸。呢一啲 alpha 酸喺煲煮嘅過程呢，就會經過異構化而產生啤酒出現嘅獨特苦味嘅。咁呢一個煲煮嘅過程，除咗可以將麥芽汁嘅濃度提高同埋殺菌之外呢，亦都係可以將麥芽汁入邊一種叫二甲基硫帶有臭味嘅物質蒸發走嘅。
等寂寞到夜深 One eternity later，
咁煲煮咗1個鐘之後呢，就可以熄火，然之後呢，用冰水浸住煲過嘅麥芽汁呢，令到佢嘅溫度降至常溫嘅。咁麥芽汁攤凍咗之後呢，就可以將佢哋裝入呢個1加侖嘅大樽入邊度等待發酵噶啦。咁喺封口等待發酵之前呢，我哋就會再次用呢個比重計呢去量度一下呢一個麥芽汁而家嘅密度嘅。咁如果佢密度係唔啱嘅話呢，我哋就會用加入蒸餾水嘅方式呢去調校至一個合適嘅密度嘅。調校好呢個麥芽汁嘅密度之後呢，我哋就會加入酵母粉，然之後再組裝嗰個氣鎖等待發酵嘅。
應該唔會嘅，但係佢都會咯。係咯，佢係細得滯咯，係嘛？咁得意啊！你要再大力啲塞落去，最啲整。
我懷疑係呢個質根本係唔啱。
一定完咗。
OK 啦，搞掂。
好，搞掂。
裝好氣鎖之後呢，就會放喺陰暗地方發酵。
One eternity later，
14日之後呢，我哋就會額外加入一啲糖水喺麥芽汁入邊，攪勻之後呢，就可以入樽等待第2輪嘅發酵啦。
有少少似一個奇怪嘅工場。有啲咩奇怪？
人哋嗰啲大陸嗰啲工場，有啲人收係咩啊
One eternity later，
係啊。哇，好香啊！過咗14日之後，要測試一下我哋嘅啤酒係咪真係有酒精嘅成分呢？我哋就揾嚟我哋嘅技術員教我哋做呢一個氣相色譜法嘅。喺呢個氣相色譜法入邊，我哋有載氣，咁呢就係一啲惰性嘅氣體，咁佢嘅作用呢，就係將樣本吹入去個儀器入邊嘅。喺儀器嘅頂端呢，就有一個進氧裝置，咁就係一個好似針筒咁樣嘅嘢，就可以將我哋嘅樣本呢透過矽膠隔膜呢就打入去部機入邊嘅。呢一部機嘅主體呢，就係一個恒溫箱嚟嘅，咁顧名思義呢，主要就係我嚟控制溫度嘅。咁而喺呢個恒溫箱嘅入邊呢，就有一個色譜柱。咁呢一個色譜柱呢，就係我哋嘅樣本進入之後會喺入邊運行嘅地方啦。喺色譜柱嘅另外一邊呢，就會連接住檢測器，就從而檢測呢走出嚟嘅樣本入邊有啲乜嘢成分嘅。氣相色譜法只係可以檢測含有揮發性嘅物質嘅。咁假設我哋嘅樣本入邊含有甲醇同埋乙醇2種物質。當我哋嘅樣本透過進氧裝置進入呢個氣相色譜質譜儀入邊呢，液體樣本就會氣化，亦都會隨住載氣被吹入色譜柱入邊。 由於色譜柱內壁對於唔同物質嘅吸附性能唔一樣，咁所以唔同嘅物質呢，需要到達呢一個檢測器嘅時間呢，都會唔一樣嘅。所以我哋可以透過比較檢測器產生信號嘅時間，從而定斷究竟我哋嘅樣本入邊係含有乜嘢物質嘅。例如甲醇喺色譜柱運行嘅時間比乙醇少，咁所以就會首先產生信號。透過同已知嘅樣本比較呢，我哋就可以揾出自己嘅樣本入邊含有啲乜嘢啦。咁透過檢測呢，我哋可以見到我哋自製嘅啤酒入邊呢係含有乙醇嘅信號嘅。咁不過酒精嘅濃度呢，相對起喺出邊買到嘅啤酒同埋其他酒類呢，都係比較低嘅。不過總括嚟講，我哋今次呢個自家釀製啤酒都尚算成功嘅。雖然釀酒嘅重點係需要酵母，咁但係呢，喺人類歷史上面呢，我哋係先懂得釀酒呢，先至發現酵母嘅存在嘅。咁酵母菌呢，第一次被發現呢，其實就係由呢一個荷蘭嘅微生物之父所發明嘅第一代顯微鏡而見到嘅。隨住佢設計嘅顯微鏡呢，佢就發現咗原來除咗動物之外呢，係仲有一系列大大小小嘅微生物存在嘅。隨住微生學嘅發展呢，後來科學家就知道呢，酵母菌係喺缺氧嘅情況底下分解糖分嘅時候呢，就會產生酒精同埋二氧化碳，而呢一個過程呢，叫做糖酵解作用嘅。咁今日嘅影片呢就嚟到呢度啦，如果大家中意嘅話呢，記得要俾個 like 支持下我，同埋訂閱我嘅 channel 啦。咁我哋下次再見啦，拜拜。幾千蚊整樽咁嘅嘢真係激死我。
奮鬥狀態。